Okay, let's talk about note set 7, specifically strings, characters, and structures, and we will try to make this as clear as possible, and I'll go as slow as possible to explain everything. So let's first talk about characters. A character is created using single quotes. So I just say example is equal to hello, my name is Brett. I'll run that. If we were to type example, we can see because of the single quotes, it means that it's a character. If I do class, that will tell me it's a character, which makes sense. Now, the big thing about characters is the fact that it is seen as an array. So, for example, this will not be one row by 5 columns, meaning the 5 columns are the words. This will actually be one row by a lot of columns because the commas and the spaces and everything needs to get added together, including every individual letter. So we have this example here, which is 23 characters. If I were to call out a character, maybe I'll call out character 6. This is the same thing as writing 1 comma 6 for one-dimensional arrays. You can just write the number that you're interested in. You see that 6 is a comma. 1, 2, 3, 4, 5, 6. Excellent. So that's really cool. If I were to make an array of characters, hi, hello, how are you? Something like this. You could do this, but it is not like a normal array. So if I were to do a numeric array and say that this is 1, 2, 3, I'll do commas even in between just to kind of compare. This array, I'll even make them bigger numbers just to prove a point. This array has 3 numbers in it. So if we were to run this and we were to do size of number array, that would be 1 by 3 because it has 3 numbers in it. Numbers are doubles. If there are no spaces in between the numbers, it recognizes that as one number. So it does not see this as 1, 0, 1. It sees this as 101. It does not see this as a 2 and a 4 next to each other, or a 3 followed by a 1, etc. These are all seen as individual numbers because they're all doubles. So this case is 1 by 3. 1 by 3 array of numbers. This case here, when you have characters, it does not do it the same way. It does not care about commas in between or spaces. It will go ahead and actually combine it all together. So you can see that even though I have a comma here, this doesn't matter. So I do size of this. It is not 1 by 3 like the numbers. This is actually 1 by 16. The only difference is really between this and the top one is that the spaces and the commas are included. In this case, I don't have any spaces or commas inside of my single quotes. These commas are outside of the single quotes, so those are just meant to separation. But for characters, it doesn't matter the separation because it's just going to join them all together anyway. This is a row vector where we have all of our characters conjoined together. If I were to do a column vector, do hi, we'll do column, or we'll have multiple columns by using semicolon. Like that. Because this is a set of characters, we will see that this is not possible. Because if I were to do another example of a number array and say 1, I'm going to actually do this exactly to match the thing above. I'll explain what I'm doing here. If I were to try to run this number array here, you'll see it doesn't work because my top row has 2 elements. Maybe I'll draw to actually show this. Cool, I can draw. So my top row has only 2 elements. And my next row is supposed to be 5 elements. And my row after that is going to be a bunch of elements because of the fact that's what I chose. And MATLAB doesn't like this because of the fact that the number of columns has to be the same for every row. So this first row has 2 columns, the second row has 5 columns, the third row has 9 columns. In concept, comparing this to the thing above, this is the same because this is an array of 2 characters. This is an array of 5 characters. This is an array of 9 characters. And you can't do it because of the fact, now it says line 8. This can't do it because it's attempting to do the same thing here. You can't have a matrix that is not having the same number of columns for every row. It doesn't work. So how do we fix that? Well, one thing we can do is just, for the numbers, we can just add in more numbers. Just added a bunch of zeros. I need 9. 1, 2, 3, 4, 5, 6, 7, 8. I think that doesn't work. Let's try that. Let's see if that works. Now, if we do number array 2, we will see that because I added in all those zeros, I have now, excuse me, I have now made it so that every row has the same number of columns, which is 9. Now, for the characters, I'll put this out for now. We have the same issue. So in order to fix that, like we talked about in the notes, we have to include extra spaces. So this is really tedious and annoying. You would never really do this, but 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now if we run it, it does work. You can see that I have this array that's 3 rows by 9 columns. And it doesn't have to be spaces. You know, I can do whatever I want. I can do 1, 2, 3, 4, 5, 6, 7. I can do dots if I want. 2, 3, 4. I can do that. You know, that's fine. Whatever I need to do to get it to be the same number of columns for every row. Okay? That's how we understand putting together characters. The other thing to note is that numbers or not really numbers, any character has a number associated with it. So I'll pull up the ASCII table just to kind of illustrate this. ASCII table. Maybe this is a good website. This kind of like the one. Where's the one I saw the other day? This one. This is a good one. So here we see that every character, space, exclamation mark, all these characters, numbers, capital letters, lowercase letters, they all have a certain value associated with them. So if I am going to try to add characters together for some reason, like if I do 3 plus 5 like this, this is not going to be 8. This will end up being some miscellaneous thing based on the ASCII table. So coming here, we see that the number 3 has a value of 51. And the number, what did I say? 5. The number 5 has a value of 53. So if we add those together, it should end up being 94. Oh, maybe I did math wrong. Let's come back to ASCII table math. Yeah, 994, 104. Those 50s. So I'm going to pause this for a second. Sorry about that. So if we were to try to add characters together, they have values associated with them. If I were to do H plus, I don't know, A or something, these have ASCII numbers related to them. So if I were to run this, you can see that I end up getting a random number based on the ASCII values of those letters. So H, lowercase h is 104, lowercase a is 97. So that ends up being 201 when you add them together. Coming back to matrices in general, let's say I have a matrix A as 1, 2, 3, 4, 5, 6, and I have a matrix B that is 0, 0, 2, -1, 1, whatever, doesn't matter. If I were to do A, we'll actually run this first. Here's A and here's B. If I do A plus B, it will add together all the things that are in the corresponding position. So this 1 will be added to 0. This 2 will be added to 0. 3 will be added to 2. 4 and -1. 5 and 2. 6 and 1. So if we add them together, you'll see that what we just said is true. 1 and 0 is 1. 2 and 0 is 2. 3 and 2 is 5, and so on. So the addition will add things in the corresponding spaces in your matrices. The same is true of characters. So if I say, some random thing is hello, and then I were to add it to Brett, we are adding the ASCII value of H with the ASCII value of B, the ASCII value of E added by the ASCII value of R, and so on, because that is what we do with characters. So I do char1 plus char2. We will get an array that is 5 numbers. This is H and B added together. This is E and R, L and E, L and T, and O and T. Okay. If I try to make it so like I have something like this, what do you think happens? Just like adding numeric arrays, we cannot do this because they're not the same size. For addition, what that means is, come back here and say that A is 1, 2, 3, and B is just 1, 2. You have to add element by element. So if I try to do this, we'll count that up for a second. Up here. If we try to do this, we'll have an error for the same reason, because of the fact that there's no third space here. So if I include a third space, then I can add it. Without a third space, I will have an error. Same thing here. If I wanted to add these things together, I can include a space. 1, 2, 3, 4, 5, 6, 7, 8. Now I can add them together. And again, the results will be stupid. But now I can do it because of the fact that I have 2 vectors that are the same in length. So if I look at the length of char1 and the length of char2, you see that they're both 14. And because they're both 14, I'm able to add them element by element. Okay, so I hope that that clears things up with characters. I'm going to look at the note set to make sure that I didn't miss anything with characters, to be fully notes. Give me a sec. Is there anything that I missed? When it comes to characters, we talked about length. We talked about addition. The one thing that I didn't mention yet is that because it is a matrix, I can extract elements the same way. So if I say test is equal to hello, my name is Brett, Slim Shady. So if we come to here and run this, actually, let's clear everything first. If we were to run this, if we look at size of test, we'll see that test is 23 characters. If I want to extract just one element like we did before, I can do, I can put in a random thing and it'll give me that element. Man, I'm getting lucky with my choices. Okay, there's a B. 19 is the first letter of my name. If I wanted to extract a group of letters, I can do something like I want the letters 1, 5, 7. You always group numbers with brackets. That will give out number 1, number 5, and number 7, which is the space. That was an accident. I wanted to get the M, but that's fine. So if you do that, it'll extract those letters as a character. Another way to do it is with a list. If I were to say I want elements, 7 to 9, this is character 7, 8, and 9. So it'll just extract those 3. I can do 1 to, I can extract the whole thing if I want. 1 to length of test. Length of test is 23, so it'll extract the whole thing. I can also go in increments, 1 to 2 to, I don't know, 23, whatever. And it'll spit out that because it's going to go in increments of 2. It starts with 1, it'll go to 3, 5, 7, 9, and we're just going up by 2 every time. And every time we do this, we're just getting a new character from the name. Holo Unima, that's bet. Cool. So that's one thing that we can talk about that is in the note set. Okay. So at this point, I want to talk about strings first. Because when I originally did this, I talked about cells right away. Because typically we want to solve this vertical array problem with cells. But let's talk about strings first. And then we will conclude with cells. So let's say that strings. Now let's just say another example. The difference between strings and characters in execution is using a double quotation. So this is a string. If you run this, you will see it's in double quotes. If I do class of that, it will tell me that it is a string. The main difference is that a character is an array that has an element for every single character that is present inside of it. While this will just be one by one, it sees the entire thing as one unit because it's a string. So if I try to do example of, if I want to extract the S, this S, I can't do it because this is seen as a one element variable. Okay, that's fine. What's cool though, because of this, I don't need to worry about this whole weird concatenation thing. I'll say, my array, I'll say, hi, hello, how are you, like we did before. Before when we did this, we'll come back up. We have this here. We will see that we end up with all of these guys added together when it's a character. When it is an array of strings, it will actually see it as 3 separate entries. So if I were to do size of array, it wouldn't be 1 by 26 or whatever. It'll be 1 by 3 because there's 3 separate entries. And even if I have spaces here, it's the same thing because of the fact that entire thing is within one body of quotes. This is seen as one example. If we were to make this vertical, that is okay. Hi, hello, sup. So if we run this, we'll see that that's okay. They do not need to be the same size like we had with characters here. With characters, when we try to do columns here, you had to make sure that the number of characters matched within each column. With strings, you don't have to. Easy peasy. In regards to adding strings together, I can just, when I say adding, I mean creating sentences. So maybe I'll say word 1 is hello. Word 2 is I. Word 3 is Brett. Hello, I, Brett. Hello, I, Brett. So if we come to here, we'll suppress all these just so we don't see them. And if we say our sentence is word 1 plus word 2 plus word 3, what do you think we see? Do we see hello, I, Brett? We don't see the spaces because I didn't include them. So if I were to say hello, I'm able to do a comma, I space Brett. Now, if I do that, now I actually have a sentence that we're rolling with. Okay, that's cool. If you try to do math with strings, it does not do the same thing as characters. I'll say num1 is, 20. Num2 is 41. If I do num1 plus num2, this will not be, there's a few things you might think it would be. Is it 61 because 20 plus 41? No, they're not numbers. They're strings. Okay. Is it adding in arrays like we did with the characters? Meaning, do I add 2 plus 4 based on the ASCII values and get 106 or something? Then add 0 plus 1 based on the ASCII values and get 110 or something? No, not characters. What we end up getting is literally these two things back to back and be 2041. Because I'm just taking the strings and concatenating them and putting them right next to each other. If I put spaces, then it'll include a space between them, and so on. Cool. To go back and forth between strings and characters, maybe I give you a character. I'll say that this is hello. If I want to make that into a string, and again, we'll just confirm the size of character. If I run this, you'll see it's 1 by 5. If I were to convert this to a string, I can use the string command. So I added a bunch of G's here to make it different. Maybe I'll just say hello string. Let's do that. Hello character. So now if I do this, let's go ahead and we'll display everything. We first see hello character, which is just the character hello. That's 1 by 5. We converted it to a string using the string command, and now it's 1 by 1. Cool. Nothing crazy. Similarly, if I have a string at first, say goodbye string, if I were to look at the size of that, that would be 1 by 1. If I were to convert it to a character, I can just use the character command, which is char. We run this, we'll see our string is goodbye, 1 by 1. We've used this character command to convert it to a character. It is now 1 by 7. Cool. So that's strings and characters. The last thing I want to talk about in this video is cells. Cells can store any data type. You know, even at the same time, I can store strings, doubles, which are numbers, characters, whatever I want, structures inside of the cell. This is basically used for storage and not for functionality. Because the problem is I have a cell, and if I store something in the cell, I can't really use it in the same way that it's been stored. So for example, if I store a number in a cell, I can't use it like a number. So let's give an example. Let's say I do, just example. And I say, we'll make a cell, and we make cells with curly brackets. This is a lot different than using these square brackets here. We'll use curly brackets. And maybe I'll just include a bunch of numbers for now. 3, 5, 4, and 5. So if I run this, you'll see that I have a cell array that is 1 by 3. Okay. If I wanted to do math, example of 1, for example, example of 1 would pull out the 3. If I tried to take that answer and add it to things, it doesn't work because I cannot add cells together. It doesn't work. So again, the 3, 4, and the 5 are just in there for storage. I can't do anything with them. We'll come back to how to actually get it out of storage in a second. But let's say we have size of example. See that it's 1 by 3. If I were to make this a bigger number, it would still be 1 by 3. I'll message Carson back in a sec. It'll still be 1 by 3. If I take the example, you'll see that I'm storing this whole number in there. I'm storing this whole number and this number. It's not like strings or characters. Well, it's definitely not like characters. It's kind of like strings. But the thing is, though, you cannot access these numbers. So what's the point? Well, maybe I want to store away a lot of things. I'll do a different example. I'll say this is my, string. I don't want to call it string. That gets confusing. Let's call it, hello. I'll call this one as a character. Hi. I'll say that this is 17. So again, these are seen as 3 different data types. This is a string, this is a character, this is a double. If I run this, I don't get any errors because it's just going to store it. If I do class of example 2, it'll just tell me it's a cell. I can't really extract the thing from it. So for example, let's say I do, my hello word, or I don't know, I'll say example two of element 1, comma 1. So example 2 is the variable name. So ignore that 2. It has nothing to do with anything. Maybe I'll just delete it for minimizing confusion, since we're basically done with this. If I do this, we'll see that we have our array, which is 3 elements, and then I extracted the first element in the cell, which is hello. If I try to do the class of that, it'll tell me that it's a cell. It doesn't see it as a string because it's in storage. I have to get it out. It's in the world. Really, I've been saying in class it's a world where characters don't exist, but really it's a world where no data types exist. It's just cells. And to extract back the data type, I need to do something that we'll talk about in a second. So I can continue calling things out if I want. This will go ahead and extract each of those individual cells. Suppress this one. Hello, hi, and then the number 17 in that order. If I try to do 1, comma 4, it'll give me an error since that cell doesn't exist. Index in position 2, which is this, must not exceed array bounds, which basically is 3 because I have 3 things in here. This is dependent on my variable. So in the cell are my data types that I'm storing away. Now, if I want to access them again, I will use curly brackets to access original data types. So if I do example of 1, comma 1, let me suppress all these. This means, what is this error here? Okay, don't worry about that. I don't know what's doing that. So if I were to do this now, this is saying to go to 1, comma 1 and bring it back to life. So let me show you the difference. If I do example of 1, comma 1, let me clear these. Example of 1, comma 1, example in curly brackets of 1, comma 1. This is a cell. This is a string. I have brought back the data type associated with it. I basically went into my storage locker and pulled out this box and all of its contents, including the string. Okay. So if I did class of that, now we see that it is a string because of the fact that we have brought it out. If I have it as parentheses, parentheses means I'm accessing the cell. So you see that without the brackets, the curly brackets, it just is still a cell. I haven't extracted it from the storage unit. Maybe I'm just looking at it, but I haven't taken it out. Again, this is for storage. Okay, cool. What else? So let's say we do the next one, example of 1, comma 2. So that means that I am going to get out the word hi, and that will be of a character. If I wanted to do this, it knows to convert this element to its original data type, which is hi, and then I'm going to go to the second letter in that new, in the data type itself, which is a character. What do you think happens if I do that? I'll let you think about it for a second. Or you want to pause it, you can, because this is a good question. So to answer the question, this is extracting out the first element in this cell, which is hello. Hello is a string. And then I want to access the second element in that string. That's going to give us an error because of the fact that example of 1, 1 is a string, and therefore it is only 1 element wide. If I try to access the second element here, I do not get an E because of the fact that it is not a character, it's a string. Now, if you wanted to get real fancy, you could, we know that this is, example 1, 2 is a character. Maybe I convert it to a string. Maybe this would be my new variable. And then I can access the E if I want. Oh, sorry. Oh, I'm sorry. I'm being dumb. Example of 1, 1 will extract out the string. I will convert it to a character. Once it's a character, then I can actually go through this matrix. So new of 2 will be what? E. Because of the fact that I have extracted this from the cell. It is a string inside of here. I have converted it to a character. And now I can access the letters. I hope that that makes sense. Let me see if there's anything else about cells that I want to talk about. But yes, the general idea. Yeah, okay, that's fine. So the general idea is this is storage. I can access those boxes if I want. I can look at them just by referencing them. But if I want to actually unpack them, I have to use curly brackets to bring it back to the normal world. This is our portal into and out of the world. Please let me know if you have questions. And yeah, I will see you during test day. Bye.